Alright, this is like take number, I don't even know.
94.
94, Nick says. So here we go. Got y equals 3 secant 3 times x minus pi over 6 minus 1. So I'm going to go ahead and jump right in. And over here I've got 6 things that you are required to calculate: period, asymptotes, domain, range, phase shift, vertical shift. It's definitely a lot easier to do the asymptotes, domain, and range after you do the graph. Well, range you could do right now if you wanted to, but I'll wait. Let's start with period. To calculate period, we want to go 2 pi divided by b. B is the number in front of x, which happens to be 3. So it'd be 2 pi over 3. So there's my period. And I can go ahead now, and I'll go ahead and put that up in that blank space here. I can go down on my graph, and I can go ahead and lay down one period of the function. So I'm going to go out 2 pi over 3. And I'll go half of that, which is pi over 3. Half of that, which is pi over 6. And then I know I'm counting by pi over 6's, so when I do my count, I can go 1 pi over 6, 2 pi over 6, 3 pi over 6, 3 pi over 6 right here, which is pi over 2. And since I know I'm going to have a phase shift, notice up here I do have a phase shift, I'm going to go ahead and put a couple marks to the right, just in case. And then I'll go ahead and do my 4 marks to the left. I don't even know how many marks I'll use to the right there. I'm going to make my left a little bit better. These aren't as good as I'd like them. So let's see if I can get my eraser out and erase those. Yeah, there we go. So here's one, here's one. Okay, so then we have negative pi over 6. I don't even think I'll use all these, but we have them just in case. Negative pi over 3, negative pi over 2, and then negative 2 pi over 3. Okay, so there's my 2 periods, and if I want to go out to the right, I can go ahead and label these 2 also. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. That would be 5 pi over 6. And then the next one would be 6 pi over 6, which is pi. So now let's go ahead and write down the rest of this. If I look at this graph closely, I know there's going to be a phase shift. It's subtracting pi over 6. So I'm going to go right pi over 6. So I'm just going to write down a right pi over 6. My vertical shift is going to be right here. It's down 1, so I can go ahead and put, since I'm subtracting 1, I'm going to go down 1. And so I've got my period done. Now I'm going to go ahead and do my vertical shift. That should always be next. Figure out where your middle's at. So I'm going to locate my new middle. And that vertical shift's really important because it shifts the whole graph down 1, so that when you go to locate your asymptotes, you're not really looking where the graph's going to cross 0. You're going to look at where it crosses negative 1. So now that this is, and since I'm graphing secant, which is really like graphing cosine, I'm going to go ahead and, if I was graphing cosine, the amplitude would be 3, so I'm going to use that here. So if I'm here, I know I'm going to have some marks. Let's just put a couple marks above here. I don't know how many I'm going to need yet. We'll look at that in a second. Put a few. So if I'm graphing cosine, if I was graphing cosine, here's the middle. Cosine would start either up 3 or down 3 from the middle, depending on if you flip it or not. Since it's not flipped, it'd be up 3. So I'm going to go up 1, 2, 3. So it actually would start here, but also have this pi over 6 shift to the right. So I'm going to go over right pi over 6, which would place me right here. So I'm going to go ahead and mark that spot, and that's at pi over 6 too. Now what that really tells me is that if I was to plug pi over 6 right here, if I was to plug that into this equation, I would get 2. Think about it. If I do pi over 6 minus pi over 6, you get 0. 3 times 0 is 0. Then you have secant of 0. Secant of 0 is really 1 over cosine of 0. Since cosine of 0 is 1, you really get 1 divided by 1, which is 1. So all of this right here would equal 1. 3 times 1 would be 3, and then 3 minus 1 is 2. So you could see how you would get 2. So now when I graph it, since that's my starting point, cosine goes to the middle from here, and then it goes to the bottom, which is down 3, and then it goes back to the middle, and I'm going to finish this off, I'm going to go one more past where I normally would go because I shifted it right. That makes sense because I shifted one tick mark to the right. I'm going to go back to the middle here, and then down to the bottom, which is down 3, back to the middle, and then up 3, which is up here at 2. So there's my cosine graph. where the cosine graph crosses my new middle, which is at -1, will be where my asymptotes go. So I'm going to sketch in those asymptotes as carefully as I can. So there's an asymptote there. There's an asymptote. Here's an asymptote at the y-axis. The y-axis is actually an asymptote here. And there's an asymptote everywhere, an asymptote. Oh my gosh. And then finally an asymptote here at 2π/3. And sorry, my dash lines are getting a little sloppy. And then what I do is I go to the peaks and valleys and I draw in my hats. I'm going to have a hat up here, or half a hat. Here a hat down. Here a hat up. Here a hat down. And here a hat up. And you should see that I have 2 full periods of the graph done. Now I can give the asymptotes, domain and range. The asymptotes would just be, remember, it was start. You had to have a start asymptote. Well, since a start asymptote, I could use 0, since there's an asymptote at 0, so it'd be 0 plus. And between these sets of asymptotes is half of the period. You complete a full period between 2 sets of asymptotes. So this ends up being half of the period, p. So if the period is 2π/3, if you do half of that, it's π/3, and then it's multiple, so it's π/3k. And the domain would be x cannot equal the asymptotes, which would just be π/3k. You don't really need the 0. The range would be y is greater than or equal to 2, or y is less than or equal to -4. And there's your secant graph with the hats and asymptotes all labeled.